Okay, this is probably where I might suggest that we start as well. The first one is just a bit of an introduction to redox, and you might be a bit like, oh goodness, what is that? The only thing I want you to take out of that first video is that oxidation is a loss of electrons and reduction is a gain of electrons. So now we're going to be able to figure out, how do I know, looking at a whole equation, whether or not it's a redox equation? And that's where these guys come into play. These guys are called oxidation numbers. And what we find out here is that, sorry, here we go, up the top here. To identify them, we need to use these oxidation numbers. Anything that undergoes oxidation, so anything that undergoes oxidation will always increase in its oxidation numbers. So this is at the top of your second page there. So for example, the oxidation number is 0, goes to +3. So that means, yes, this is oxidation. Anything that goes down, yes, anything that has a decrease in oxidation number, and I'm going to talk to you exactly how to do this in a second. So it went from +2 to 0. So this one here goes down. It is called, it is a form, sorry, it shows us that reduction is happening. All right, so let's go have a look at our rules and then we'll do a few practices. All right, number one rule, if you are a free element, so if you are a noble gas, if you are another kind of gas or something that is just one element, yes? So sodium on its own, phosphorus on its own, neon on its own, hydrogen gas on its own, oxygen gas on its own, nitrogen gas on its own. What else have we got? We've got chlorine gas. We've got fluorine gas on its own. What else can we have? Any of our other noble gases. So argon. Now, anything that is just one element, we say it has an oxidation number of 0. So what I do is I go through and I put in those oxidation numbers first. The next one that's really easy is any one that's a simple ion. So if it's in, say, group 1, you know it's going to have a charge of +1. If it's in, this is a bit off, sorry. So that, there we go. So if it's in group 1, we know it's going to have a charge of +1. If it's in group 7 or 17, sorry, we know it's going to have a charge of -1 because that's the charge on the ion. Same with tin, same with the nitrogen here. Now, in some compounds, there are certain elements that have what we call fixed oxidation numbers, and that's where we go to next. So the next one we go to is that main group metals are always going to have their oxidation number equal to their valency. So that's your sodium will always be +1. Your magnesium will always be +2. Yeah, potassium will always be +1. Yeah, anything in those main group metals, they will always have an oxidation number equal to their valency. The other exception here is, sorry, the other one we've got here is hydrogen is always going to have a +1, unless it's a metal hydride, in which case it has a -1. So what do I mean by a metal hydride? So I'll see, just give me 1 second. I'm just going to make sure. We don't come across these very often, but if you say had tin hydride, so it's anything where a metal is bonded to a hydrogen, you can see that the tin will have an oxidation number of +4, and sorry, +4, and the hydrogen will have a -1 in this case. So yeah, it's very rare that we come across metal hydrides, but that's what it is. Oxidation numbers are always going to be, for oxygen, we're always going to have -2. There are some exceptions here. Anything that is hydrogen, say peroxide, so H2O2, yeah, you can see that the H will have a +1 and the O will have a, oh, sorry, very frustrating that I'm not able to draw properly today. Yeah, so that one was +4. And the, sorry, a peroxide, so hydrogen peroxide is H2O2. Because of the fact that the hydrogen only has an oxidation number of 1, the oxidation number of the oxygen won't be -2 because there are 2 of them, and that would outbalance the hydrogen, so it's just going to be -1. The sum of the oxidation numbers in a compound is always going to be 0. So long as the compound here, this is a neutral compound, as it doesn't have a charge. So we're going through all these rules, but we're going to practice them in a second, and it gets a lot easier that way. And the sum of the oxidation numbers in a polyatomic ion is always equal to the charge on the ion. So for example, NO3 minus, yes, whatever the charge of those ones in the middle there. So if we said that N has to be +3, the O has to be 2 minus. So then it turns out that the sum of those, because there's 3 of those, so we end up with a -6 +3. This must be actually +5 in that case, yeah, to get there. So if 2 of the above apply for any particular compound, the most electronegative element takes the valency first. So we're going to go through that with some questions. So let's have a look at the oxidation number of chromium in each one of these scenarios. So the first one here is chromium plus. Yeah, so it's just a single element. You think that it's 0, but because it's got a charge on the ion, that's what its oxidation number is going to be. So its oxidation number is just going to be +1. The next one is Chromium O4 minus. So we know that this O there has an oxidation number of -2. We also know that there are 4 of them. Yeah, so overall it's going to be contributing -8. Yes, are you happy with the fact that it's contributing? This bit here is contributing -8. Yeah, overall we have to get to -7 because, sorry, overall we have to get to -1. So we're going to have to add 7 here. Yeah, so that this chromium over here is going to have to be +7 to balance out the 8 negative charges and leave us at -1. The next one down here, we've got chromium, oh, so annoying. We've got chromium 2O3. So we know that the O3 part has got -2, but there are 3 of them, so it's actually -6. So the chromium 2 here has to be +6, and then there are 2 of them, so the chromium 2 is equal to, chromium is equal to charge of 3+ there. This one here, chromium 3+, it's just going to take on the charge of the ion. This one here is a little bit more complicated. And if you haven't paused yet, I want you to pause and try and do this one on your own. So our total has to equal to -2. So if I know that the chromium 2, yeah, O7, 2 minus. So I know that this has got to equal to -14 because each oxygen is -2. Overall, I've got to get to 2 minus. So this is going to be +12 for both of those chromiums. Now, because there are 2 of them, I'm going to divide by 2. So my oxidation number should be +6. So we have +1, +7, +3, +3, +6. The last one here, I haven't really given myself enough space here, so I'm just going to rewrite it. O3 -6 +6. So that one there is going to equal to +6 as well. So let's just check our answers. So it should be 173366. They're all pluses. 173366. Good work. I want you to try these ones, and then I'm happy to go through them in class, or actually I might just go through them in a second, but I really think it's a good idea for you to pause and try and figure these out yourself. So make sure you pause, and then I'm going to go through them with you. Hoping that you paused and now we can go through them. So I'm going to try and write really small, actually really small above them. So I know that the hydrogen has got a +1. I know that there's 3 oxygens, so there are -6 overall. And then overall, this one in the middle here is going to have to take us back up to neutral. So it should be that the oxidation number of the nitrogen in this one should be +5. Yeah. In this case, we know I've got -2 over here for the oxygen. This one should be +1 because there's 2 of them. So I'm going to end up writing that out, and I'm going to say N equals +1. The next one here, I've got -6 because there are 3 oxygens. So this is the third one down. So this is going to be +6, but there are 2 of them. So I'm going to divide by 2. So it should equal to +3. This one down here, I've got -4. There's only one of these guys, so it's going to be +4. If you don't know why this is -4, there are 2 oxygens, and each one of the oxygens is got a -2. In this case, we've got a -2 on this oxygen. So this one's going to be +2. +2. This one here, we've got 5 oxygens. So I'm going to go -10. That means this is going to be +10 divided by 2. So this means it's equal to +5. So what we should get in this time around is we should get 513,425. 513,425. 513,425. Excellent. Let's just go through the very last one here. We're going to determine the oxidation number of sulfur in these compounds. So let's give it a go. Pause and try and figure it out yourself first. All right, I'm really hoping that you've tried to figure this out. And if you haven't figured it out, stop the video, go and figure it out yourself. Let's go. So in this case, stop giving me the answers. In this case, we can see that my overall charge has got to equal to -2. So I know I've got -8 there. So I'm going to go -8. I've got to get back up to -2. That means that sulfur has got to have a charge of +6. This second one here, I know that it's going to have a +2 charge because there are 2 hydrogens there. Each hydrogen has got a +1. So that means this one is going to be -2. This one here is just a whole element, so it should be 0. The next one here, we've got -2. We've got 2 of them, so it's actually -4. So this should be +4. Down here, we've got 3 oxygens, which is a -6. +2 over here, so this is going to be +4, and there's only one of them, so it's +4. Now, the chlorines have got a charge of -1, so there are 2 of those, so it's a +2 over here, only one, +2. So let's just check our numbers. We've got +6, -2, so 620,442, but the second 2 is a minus. 620,442. So hopefully, that's a really good run through of how to calculate oxidation numbers.